Thank you, Maeve. Okay, so introduction to cryptocurrency and Web3. So what I'm going to try to do is I'm going to begin by talking about the original and most well-known cryptocurrency, which is, of course, Bitcoin. So that's the one you might have at least heard of before, that at some point in the past you might have watched a video on YouTube about, or that you might have heard in the media, at least in some kind of context, or possibly even you had a friend who became fabulously wealthy back in the early 2010s because they bought some Bitcoin. So I'll talk about Bitcoin and its focus on money. So Bitcoin is supposed to be a new type of money. And then we'll look at the evolution of cryptocurrency away from this focus on Bitcoin's sort of money emphasis toward this idea of a world computer, which is exemplified by Ethereum, which is the main, or actually the only real competitor to Bitcoin. So Bitcoin is the #1 cryptocurrency, Ethereum is the second, and then after that there's a steep fall off in terms of what we call market cap, or how much money is involved in it. And then finally, I'll emphasize how the situation has evolved today. So the situation today is something called Web3, where the technologies behind Bitcoin, the technologies behind Ethereum, have now become more focused on the idea of reinventing the web instead of simply reinventing money. So the idea is to create this new type of parallel internet which challenges the old internet of, say, Facebook, Meta, Google, Amazon, and all that kind of thing. So basically a little bit of a potted history going from the original through to the main contender, and then like the current landscape or where things hang today. Okay. Now, the prehistory of cryptocurrencies, it goes all the way back to the 1980s, believe it or not. So this is with a group of people known as Cypherpunks. That's C-Y-P-H-E-R, instead of cyberpunks, like the hackers or the game. So Cypherpunks were a group of digital privacy activists. So these were people who were involved in the creation of the internet all the way back in the 1980s. So they were really hands-on, very, very familiar with the internet in its construction, the earliest phase. And what they could see is that the internet seemed to be going in a very specific kind of direction. It seemed to be going in the direction of where it's ended up today, which is what we call surveillance capitalism, where basically when you use the internet, your data is monetized, packaged, and then resold to various different advertising agencies. So in order to use like Facebook or Google, you essentially sell your private data for the free service. And they could see that that's the way that it was going, and they didn't like this, right, because they were interested in like securing privacy and anonymity on the internet. Now, in particular, the way that they believe that this happens is through the problem of centralization. So from the cypherpunk perspective, the more things are centralized, so the more that power is concentrated in a small number of people, whether that's an organization, a company, or simply a group of people, the more potential there is for corruption. There's too much power concentrated in a small number of people's hands, and that leads them to inevitably, according to this philosophy, not me saying this, eventually sees them exploiting their position, in this case by exploiting your data and selling your data. So that's what the cypherpunks were concerned with. Now, one of the most important aspects of all this from the cypherpunk perspective is the idea that your financial data in particular is extremely revealing about you. Your finances reveal your financial situation, your financial health. They reveal your preferences. They reveal where you are when you're at the petrol pump. They reveal all kinds of things about you. And so financial privacy is basically the holy grail. If we can solve financial privacy, we'll be in a good position with our privacy overall. Okay, so in October the 31st of 2008, so Halloween, there is an email sent to what's known as the Cypherpunk mailing list. The Cypherpunk mailing list is where they hang out and talk about all these financial matters. And this is 2008. So the Cypherpunks have been working on digital money at this point for over 20 years. And they couldn't solve this problem. And in this email, we get an announcement from a pseudonym called Satoshi Nakamoto. So an alter ego or an alias Satoshi Nakamoto, whose identity to this day remains unknown. So we don't know who this person is. We don't know who made Bitcoin. It remains a mystery, and it's probably the greatest mystery on the internet. Who made Bitcoin? Who made cryptocurrency? It's a big question mark. So this pseudonym says, I've invented a new type of money. Bitcoin, a peer-to-peer electronic cash system, the name of the white paper. And this tells us more or less everything you need to know about what Bitcoin is. It says Bitcoin, of course, is the name of it. The other thing is that this type of money that he's introducing is going to be peer-to-peer. So what do we mean by peer-to-peer? It means we're going to transact as individual, so an individual being a peer, to another individual who's also a peer, and we're going to transact directly with one another with no intermediaries. There's going to be nobody in between our transaction. There's going to be no bank, no payment processor, no Revolut. We're going to transact as peers directly, equal basis, not taking data from each other, not revealing any financial information about ourselves. So it's going to be a peer-to-peer network, and that's really what that means. That's the technical name for individual to individual. Now, the other aspect that he tells us here, and this is a little bit of an old school term, you wouldn't hear people use electronic cash anymore. These days, we would say digital cash. But what he's suggesting is that this is going to be a money that's like cash. So it's not going to be a money that's like, let's say, Revolut or your bank, where you sign up on an app and you're using the ledger of a company. It's going to be more like your situation when you're transacting with people using cash. So if I decide that I'm going to buy a bike from you, and we exchange, right, I give you €50 a note, and then you give me back a bike, then that transaction leaves no underlying information about the transaction. There's no data, there's no server, there's nobody that's collecting that information. We're simply transacting directly peer-to-peer in a way that doesn't reveal any information about ourselves. So it's anonymous. And so Satoshi is suggesting is that Bitcoin is going to be like cash in the real world, where you can exchange value with other people and you are not expected to kind of give up everything about yourself or leave a record about your activities. So it's anonymous in that way. So like it's going to be like cash in the real world. Okay, so the goal of Bitcoin is decentralized digital cash. So decentralized means we're not going to have any kind of central authority in the middle of the system. There's not going to be anybody who has control over, say, a money ledger, like a bank or a Revolut or PayPal, somebody who's tracking the money. There's going to be nobody with that direct power to like keep track of all the money or even reverse transactions or anything like that. It's going to be digital cash, so it's going to be anonymous in some kind of way. And then we have these two techniques, and I apologize for this section in particular because this is where I'm going to try to explain how does Bitcoin work. Now, normally this would take me around 4 or 5 lectures, which might be between 8 and 10 hours of material in my undergraduate class. At postgraduate, I kind of squeeze it down even further. But this is like the ultimate extreme slim version of Bitcoin that can possibly exist, the minimalist version. So I'm going to talk about peer-to-peer networking, which is very, very important. That's sort of the basis, the foundation of everything. And then I'm going to talk about the infamous blockchain, which you may have heard of just in passing. So blockchain was actually invented by Nakamoto. Blockchain is invented for Bitcoin. That's where it comes from. It's not the underlying technology behind Bitcoin. It is originally Bitcoin itself. And then later on, people apply it to different things. So peer-to-peer networking, and then the infamous blockchain. OK. So this is the Bitcoin peer-to-peer network. This is all that Bitcoin is. Bitcoin is just a network of people that are all running the same software. At heart, that's all that Bitcoin is. There's no CEO, right? There's no company. There's no foundation. There's no organization. There's no corporation. There is nothing behind Bitcoin. There's no central authority. Instead, it is simply going to be all the people who believe in the Bitcoin project, running the same software and following the same protocol or the same rules. That's all that Bitcoin is. A little bit of a miracle that it's as successful as it actually is. So how does this peer-to-peer network work? Well, essentially, you have what are known as open source software developers. Open source means that they're going to be working on this software for reasons that aren't financial, right? They're not doing it to make money. They're not doing it because they work at a company. They're doing it on a purely volunteer basis because they believe in the idea of anonymous digital cash. So that's an open source ethos behind Bitcoin. So we have these open source volunteer developers. They're going to work on some software, and they're going to release and update the software every, say, 6 months, right? They're doing this as a volunteer basis, remember. So there's no company, there's nobody pressuring them to do this. They can leave at any point, right? And anybody can be a developer. You could decide after this class, after this lecture, that you could go be a developer on the Bitcoin network, and there's nobody that can stop you, right? It's completely open. So we have these developers, and what they do is they release a version of the software, and what that software encodes, or what's in the software, are the rules of the Bitcoin network, right? The rules for the sending and receiving of a type of money called Bitcoins, the currency, the one that's worth $29,000 as of today, probably going down to $27,000 in an hour or two, probably going back up to $31,000 2 hours after that. But at the moment, right, that's the currency that they're OK, so that's what the Bitcoin protocol is. It's just the rules that everybody's going to follow. And I'm going to talk about one of the rules, the blockchain, in the next slide. But basically, the software has the rule set encoded in it. So if you're a user, how do you join the Bitcoin peer-to-peer network? Well, you go to the Bitcoin website, or you go to GitHub, where other open source projects are, right? You know, GitHub, where people post their code. And then you download the Bitcoin software, and then you run the Bitcoin software, and when you run it, you become one of the peers in the Bitcoin peer-to-peer network. So when we say the Bitcoin peer-to-peer network, it's just people who've downloaded the software, run the software, which is then sought out other people who want to belong in the network, and then collectively, we are all part of this giant network. So as long as somebody is running the Bitcoin software, Bitcoin exists. Really, as long as two people are, because then it would really be a full network. So the Bitcoin peer-to-peer network, it's just users downloading some software that's being created by these open source developers, and it's going to encode some rules for the sending and receiving of a type of money called Bitcoins. Okay, sorry, the other thing I want to then mention is, here's where the conundrum comes in. If we have a money system, a normal money system, so let's say I want to send and receive money on the internet, and we're doing this through PayPal. This is a relatively easy situation for PayPal to deal with. They're directly in control of the ledger, right? So they have like direct control of the ledger of people's balances in PayPal. So when people send money to each other, PayPal can simply directly update the ledger, right? They're a central authority. They have direct control over the balances in their ledgers. Now, in the Bitcoin system, we're going to face a little bit of a problem. We also want to have a ledger of people's balances, right? We want to have a money system where when the users in this network decide to send and receive money to each other, so when they send Bitcoins to each other, we need a way to update our ledger, but we have a little bit of a problem. We don't have a central authority. We don't have a single entity who's able to unilaterally change the ledger or update the balances for us. So we're going to have to find a way to reach consensus about a shared ledger in the absence of a central authority, right? This is sort of the problem. I know that's a little bit of a weighty thing, but there's certain things that are unavoidable in describing Bitcoin. So we have a ledger, we need to update balances, but we don't have a central authority. How do we resolve this issue? Satoshi's solution to this problem is what makes Satoshi notoriously the greatest hacker, the greatest genius of recent computer science projects. Okay, so here's the solution, ish, or at least the condensed version, right, the minimal version. Don't worry too much about what you're seeing in the block itself. Okay, so when a user sends a transaction in the Bitcoin network, so when somebody decides to send Bitcoins from one person to another person, there's going to be a special class of users. And this special class of users is going to be called a miner. M-I-N-E-R, as in mining for gold, right? Not like a young person. So they're mining for gold, and they're known as Bitcoin miners. In the original Bitcoin system, up until around 2012, 2013, everybody was a miner. In fact, I was a miner. This is a Bitcoin mining rig, and that's what I used to do as a hobby. And of course, that's probably about as nerdy a hobby as you could have during that era. Nobody knew what I was up to. I just had these weird machines in my house, right? So today, basically, mining is a very, very, very specialist operation. It's these huge kind of like operations. But let's imagine, just for simplicity, that we're in the original system, because that's like the easier way to explain it. So when people send Bitcoins in the system, the miners, what they're going to do is they're going to look at the transactions that are coming in over a 10-minute window. So we're going to update the ledger, the Bitcoin ledger, every 10 minutes, which is a bit slow, right? But we're doing it in a decentralized way, so there's like a cost, right? We can't do it as fast as PayPal. Okay, so what we're going to do is we're going to gather up all the transactions, and then we're going to present the next page in the ledger to the rest of the network, right? So you're saying to the rest of the network, this is what I believe the current updated balance of all the people who've sent and received Bitcoin in the last 10 minutes represents, right? So we've got 10 minutes of activity that miners are putting together into a page in the ledger, which in Bitcoin is called a block, right? So that's the data structure. It's called a block. Okay, so the interesting thing about this is that every miner, so let's imagine everybody in this network, or everybody in this room, let's imagine we were all miners, we would all be working on a version of the ledger, or a block, at the exact same time. So concurrently and simultaneously, we are all working on the construction of the next page in the ledger, or the next block, right? So this is an interesting situation. We've got everybody making their slightly own different version of the block or the page in the ledger. So some people will hear transactions a little bit later than other people, so their block or their page will be a little bit different because based on where you are in the world. So everybody's block is going to be slightly different. So it's a little bit of a paradox here. We want to have a ledger, right, which is consistent, one ledger, and we want to have like one person be the next page in the ledger or the next block. So how do we pick one person from the pool of all the different miners? And that's going to be the thing that we try to solve. So how do we solve this? How do we pick one person to be the next page in the ledger or the next block in the blockchain? Now here's the part where I'm just going to have to say that a lot of this involves what I would just call, for the purposes of this lecture, cryptographic magic, right? This is the difficult, really difficult stuff, the cryptography behind Bitcoin, which is where we get cryptocurrency from. But the simplest version that I know of, right, and with apologies in terms of like leaving out some key steps, is that the miners are basically going to be engaged in a competition. So when they create their page in the ledger, right, that only takes a little bit of time, right? It doesn't take too long. The rest of the time during that 10-minute window is going to be dedicated to trying to find a solution to a puzzle. So they're all going to try to be finding a solution to a puzzle. So they're engaged basically in a race to be the first person to find a puzzle solution of some kind. Now the puzzle solution essentially sees them take the data from the top of the block. This is called the block header or the metadata. So this is data about data, right? So it's going to say things like, what time was the block constructed? A little kind of digest message of all the transactions, and a bunch of other little bits and pieces of information that you don't have to concern yourself with unless you get really, really into Bitcoin. So we're going to take that information as our input. We're going to put it through something called a cryptographic hash function, right? So this is the magic part. For the purposes of now, let's just call it a blender, right? So it's a blender of some sort. We take our input, the block header, we put it through a cryptographic hash function, the blender, and then it will produce an output, right? So it will produce a kind of cryptographic hash output, which you might look up later on if you're so inclined. So the miner will take the input, put it through the blender, and try to get a type of output. Now the competition is that they must find a very, very specific type of cryptographic hash output. There is a type that they must aim for. And the issue for the miner is that the only way that you can find it, the only way you can get this particular type of cryptographic hash output is you must go through it in a blunt force way, going through all different permutations. So we take the input, right? We put it through the hash function, we get an output, and it's not the right type. So it gets rejected by the network. They say, that's not the right type of output. So what do we do next? Well, we take our input, we add the number 1, and then we put that through the hash function, and then we see if it's the right one. And if it's not, okay, we reject it, and we go back. And then we do the same thing again, 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 trillions of times, right? This happens like a huge amount of times. That's why these machines, if you look at them, these are all chips, right? So all these chips are dedicated to solving that puzzle. So it used to be on your home computer, then it was on your video game card, and then these days it would be on these machines. So all they're doing is searching through all the different permutations, trying to find the right output. Now all of us are doing it at the same time, but somebody will win the puzzle solution first. So within that 10-minute window, it takes 10 minutes to find the right type of output. One person will reach it first, and that person gets to be the next page in the ledger or the next block, right? So that's how it works. There's a race, and then one person finds the right type of output, and they become the next person. Now the next block, right, let's imagine, right, the puzzle solution has been found. So now we add that block. So that's now the next page. The next person who wins the puzzle will be someone different. The next person after that will be someone different. The next person after that will be someone different. So we don't have a central authority or a single person changing the ledger. We're going to be pulling the people who have the right to update the ledger from a different person each time, from our decentralized network. So we're able to update our ledger without having a central authority. We're doing it in a purely decentralized way, all based around the Bitcoin protocol, following this sort of algorithmic method. Okay, so here's what it looks like from the walking back a little bit. So a miner constructs the block, right? So they construct the next page in the ledger. They say, like, this is the updated balances. And then they've engaged in the race to find the puzzle solution. One of them found it, and then their block is now added to the chain of blocks, the consistent historical ledger, and that goes all the way back to the original block that Satoshi Nakamoto found called the Genesis block. So the blocks are all chained together all the way back, and that's why we call it a blockchain, right? It's just a chain of blocks or a chain of pages in a ledger going back all the way to the beginning. Now the question arises, why would you bother doing this? What's the point? Why are you, why would you care? Maybe you're going to do it because you just believe in the goodwill of this project. But actually, Nakamoto realized that the better way to do this would be to incentivize people in economics terms. So what he does is he says, if you are the miner who finds the block, you win Bitcoins. Right? So you win in the original system 50 Bitcoins if you're the person who adds the block next. And then these days, it halved all the way down to 6.25, but that's still a substantial amount of money, right? If you win 6.25 Bitcoin now, you'd be a very, very happy person, right? So there's an incentivization for people to participate in the maintenance of the ledger. And then the interesting implication, there's no real, I'm just kind of wedging this in here because you might have heard of it before, but essentially the way that it works is that eventually there will be no more Bitcoins issued in 2140, and so there is a scarcity of Bitcoins, so there only will ever be 21 million. So if you've ever heard anybody say Bitcoin is also digital gold, that's where that idea comes from. In a way, it's sort of a perfect money. It's cash and gold. It's got the cash part, the anonymity part, and it's also got the gold part. So it's kind of like this perfect experiment of money. Okay. So Bitcoin, the goal, decentralized digital cash, the techniques, the peer-to-peer networking, that whole process of downloading software, running the software, connecting to other people, and then the blockchain, which I won't reiterate now, but I'll do a little bit of a quick tour of it with Ethereum. And the result, and I'm going to just throw these terms at you because you might not have heard them before. They're a little bit of kind of difficult terms, but it's no harm for you to at least hear them once. The benefits of all this, the result of all this is that Bitcoin is a type of money which doesn't require any permission from anybody to use. It is permissionless, right? There's no permission required to engage in the Bitcoin economy. You don't have to give up any information. You don't have to sign up to a bank. You don't have to give your phone number. You don't have to tell them anything. It is a completely open, permissionless form of money. And that itself is a bit of an exciting and interesting thing, at least to enough people to have kickstarted the Bitcoin economy. It's also censorship resistant. If there's no central authority, if there's no single person in control of the ledger, and nobody is able to basically unilaterally change the ledger, it can only be done through that algorithmic competition, then that means that no company, no government can ask the Bitcoin network to revert transactions. So every type of economic activity in Bitcoin is completely neutral, is seen as exactly the same, whether it's money for drugs, whether it's somebody just buying like a t-shirt. All the economic activity is considered completely neutral from the perspective of the network. So it doesn't make any political distinctions between people. Okay, so Bitcoin is, of course, the major cryptocurrency, sort of the dominant cryptocurrency for a very long time, has occupied the #1 position on the crypto market capitalization charts. So that basically means the sort of accumulated amount of money invested in Bitcoin since the beginning, right? So Bitcoin's always been #1. Now the main competitor to Bitcoin, and really the only competitor, is Ethereum. And it's actually the focus of my own research. I'm basically what they would call an Etherean as opposed to a Bitcoiner. So I'm an ex-Bitcoiner, and now I'm a convert over to the Ethereum world. So Ethereum is created by, conceptualized in December of 2013 and launched in July of 2015 by a Canadian-Russian programmer named Vitalik Buterin. The difference here is we know who Vitalik is. He invented Ethereum when he was 19. If you want to feel old and you haven't accomplished anything, this person invented a cryptocurrency that's #2 in the whole world at the age of 19. And he, in many ways, is kind of like our replacement Satoshi. He's the most respected person, say, after Satoshi, because he's like still around, I guess. Okay, so the idea with Ethereum is that instead of being a ledger, so we're not just going to have a ledger, so we're not just focused on this idea of a ledger system, we're going to try to have a blockchain, but the blockchain is going to be recording the states of computers, right? The current state of a computer or a blockchain computer. And this is going to be a little bit difficult to wrap your head around, and I would not expect you to kind of fully get what's going on with Ethereum too much, but I do think it's important to at least have some familiarity with it if you're interested in contemporary cryptocurrency today. So we're going to have the same techniques of peer-to-peer networking, so that's going to remain in place. We're also going to have the blockchain still in place, so the architecture of Ethereum is very similar to Bitcoin. Architecturally, they are very similar, right? So they don't, there's going to be very important nuances in certain regards, but broadly speaking, let's say from the perspective of someone who teaches this quite a bit, they are very nicely similar, right? You can kind of double up in teaching them. And then there's going to be something called smart contracts. And this is really going to be the innovation that Ethereum introduces that does not exist in Bitcoin. So Bitcoin doesn't have these smart contracts, and I'll explain what those are in a second. Okay, so what's similar, what's the same? Ethereum is also a peer-to-peer network, which means we have volunteer developers, open source developers who are creating a type of software. They're releasing that software in like cycles of maybe 6 to 8 months or something like that. Users who want to participate in the network, they download that software, run the software, and then they connect to the Ethereum peer-to-peer network, right? So everything is very similar in that regard, except the goal or the aim is not to have a global ledger where we're tracking the sending and receiving of a currency called Bitcoin. Instead, we're going to be hosting a giant world computer, right? So it's much more expansive and it's much richer, I hope to show as we proceed. So our aim here is not to simply track money. We're going to be tracking the state of a world computer. Now, when I say state of a computer, I mean something very similar to the way that we think about our phones or our MacBooks, right? So your phone now has a current state. Let's say WhatsApp is currently open. That's the state of your phone at this particular moment. If you close WhatsApp, then that changes the state of your computer, right? Same with a MacBook, same with a laptop, or whatever it happens to be. So the Ethereum world computer is going to be very similar. It's going to have a current state. There's going to be applications that are running at a particular moment, and then we're going to change the state of the computer every so often. In fact, it's going to be every 10 to maybe 15 seconds in the case of Ethereum instead of Bitcoin's 10 minutes. Okay, so the Ethereum blockchain, the same process where miners see transactions coming in. So they see people sending and receiving a currency called Ether. And then they're also going to be looking at this other small thing called smart contracts. These are going to be little applications that we run on the Ethereum world computer. So they're similar to applications on your phone, similar to applications on your MacBook. The difference is they're going to be on this giant global world computer where everybody can see all the activity that's happening on them. So there's this idea of like the transparency of these applications, which is very unique. So it's a little bit difficult to wrap your head around the idea that instead of your applications being entirely personal and for you, you're going to have this idea of applications that are completely public and that everybody can interact with in a completely transparent and open way. And it's going to change some of the possibilities that we can do with computing in general. Okay, so smart contracts. A bit of a, yeah, definitely another, like cryptographic hash functions, this is one of the unforgiving things to have to explain to people. So the saying goes that smart contracts are neither smart nor contracts. Right? So there's nothing to do with artificial intelligence or anything. There's nothing to do with contracts, legality. That was a mistake as admitted by the creator of the term. He said I should have called them anything else, maybe just blockchain applications, something like that. So the idea of a smart contract is it's going to be an application like on your smartphone, on your computer, but it's built specifically for the Ethereum world computer, right? So that's the general idea. It's just an application, but it's on the Ethereum world computer. So developers, people who are interested in creating these applications, they'll work on these applications, and then they'll kind of come up with some interesting new innovation, and then they will deploy or send them to the Ethereum world computer. So they will send them out to the network. The miners will see that a new application has been created, a new smart contract is being created. They'll then add them to the block, and then that will update the state of the computer. That will now say that that application has been added to the Ethereum world computer. So that's how the smart contracts get onto Ethereum, right? It's, again, a little bit complex. Now, the interesting thing is, when you create these applications, and now they live on the Ethereum world computer, there's going to be a situation where how are we going to interact with them? Like, how do you interact with a smart contract application on Ethereum? And the closest analogy that people tend to go with is the idea of a vending machine. So a humble vending machine, right, it contains pre-programmed code or sets of instructions, like press A2 and then put a euro in, and then you'll get a packet of King Crisps or something like that, right? So it's got some pre-programmed code that if you trigger those instructions by sending money to it, it will autonomously or automatically execute that code. So it doesn't require an individual or a person standing around it. It can do these instructions completely autonomously. And so an Ethereum smart contract is going to be very similar. In order to interact with it, you will send the currency called Ether to the smart contract, and then it will execute some kind of code, right? So it has some code in it, and then users like me and you can make it do things by sending Ether to it. Now, what we're going to do from now on is try to make this a little bit more real and a little less abstract going forward. But broadly speaking, we've got this goal. We're trying to create a decentralized world computer. We've got our techniques of peer-to-peer networking, of the blockchain, and now we've got these little applications added into the mix. And what we're trying to do, and what's really the result, the current situation, so 2022, what's going on in cryptocurrency, is known as Web3. So Web3 is an attempt to essentially reinvent the web on the lines of decentralization. So directly taking on the Web 2 established culture. So Web 2 meaning the centralization of the internet by Facebook, Google, Amazon, all the FANGs who basically control most of the bottlenecks of the internet, have made the internet into a little bit of a walled garden, have generated what we would call negative externalities on, say, mental health, fake news, of course, surveillance, right? Surveillance capitalism, that's what we call the accumulation of your private data to be sold on. All of those things are the target of this emerging culture, which is called Web3. And they're going to use the Ethereum world computer to try create parallels or analogs to what exists in Web 2, but they're built in a purely decentralized way because they exist on Ethereum instead of existing on the kind of older internet. So that's the ambition or the rhetoric, at least. OK, so here is the two worlds side by side. So this is my Twitter account, which would be a classic kind of like Web 2 experience, or Web 2.0 experience. So I sign up to Twitter, right? So I sign up to this application, this Web 2 application. And this Web 2 application is free, right? Or free, at least in scare quotes. And by free, what they mean, at least we all know at this point, is of course that you're the product, right? That your data gets extracted, monetized in ways which are basically invisible to you. You don't really know what happens to it once you're signed up and all that kind of thing, right? So we all have a sense that something's a little bit broken in that kind of model. So that's the Web 2 world. And then we have up here is what's known as, or what I would see as the access point into Web3. So this is a Ethereum wallet known as MetaMask. It's a very popular wallet. It has around 21 million users at the time, or at least 21 million downloads. Maybe not all of them are users. And this is going to be our way of accessing the Ethereum smart contracts. And that itself is basically going to be the same as accessing the Ethereum world computer. So we're going to use this to connect into the applications and interact with them. And these are going to exist on the Ethereum world computer, which is decentralized. So now we've got a version of the web which is sort of growing in parallel to this sort of Web 2 world. So you can see I'm connected into the Ethereum mainnet. And you can see that I'm called here account 1. I'm not Paul Dylan-Ennis, right? I'm not anybody's kind of name. They're not looking for any information about me. We're in a permissionless, decentralized culture, so they don't need any information from me. They're not going to be tracking me. It's nobody's business what I do on Web3, right? So I just want to make it clear that this idea of being if you look at the account, the address underneath it, it's a hexadecimal string of numbers and letters, right? OX, AEF, whatever. Now, if you knew the full address, you would actually be able to track me quite well. But that's why I have it a little bit scrunched up, right? OK, so this is, I'm going to go through a few examples of smart contract applications, so getting away from the abstract. So one of the problems with teaching this subject typically, right, is that you have to kind of go through a little bit of the more kind of abstract, difficult explanations of like smart contracts and so on. But really in my class, most of my time is really spent on this stuff. It's spent on the actual applications, the actual use cases that are out there, at least as much as possible I try to do this. So the first that I'm going to talk about is something called decentralized finance, or DeFi. Very nicely named, right? It's supposed to be like kind of defiant. OK, so what is DeFi? So one of the things that we can do in the Ethereum, one of the smart contract applications that we can build for the Ethereum world computer, so up here we imagine we've got our smart contract, is we can create assets, right? So we can create various different types of assets. So I'm going to begin with the most familiar type of assets, which is basically going to be currencies or tokens. Right? Now, this, in a way, is sort of the least inventive part of the cryptocurrency Web3 experience because, of course, Bitcoin is a type of money. And then what did the Ethereum people first do with their smart contracts? They create more types of money, more types of tokens. Now, there are around 13,000 cryptocurrencies, but I'm just going to focus here on the ones that exist on Ethereum itself. So the smart contract that I'm going to focus on here is the one that's numbered number 16. These are all currencies or tokens that have been created on the Ethereum blockchain itself. So what people have done is they've created smart contracts. The smart contracts encode the rules for a currency, right? So a currency, it's going to have a name, it's going to have a maximum supply, and it's going to have the ability, right, to transfer the currency from one person to another. And that's all that the smart contract application is. So if we look at Shiba Inu, which is a very popular cryptocurrency, it's what we call a meme coin, which means it doesn't really have any real backing behind it except the meme itself, the culture, the community, which in crypto can be very, very powerful. This is a top 16 cryptocurrency, which means there's billions of dollars in the mix here. So what is Shiba Inu? The creators created this smart contract, and then they say, okay, the name of this currency is going to be Shiba Inu. It's going to have a ticker symbol of SHIB. It's going to have 21 billion of the maximum supply, and you're going to be able to transfer it from account to account. That's what Shiba Inu is. When you think about it, when people see it on apps, when they see it on Binance, when they see it on Revolut, it seems a little bit more mysterious than this, but actually it's just a smart contract that some developers created, deployed to the Ethereum blockchain, and then people now have this new currency out of nowhere. And the interesting thing about all of this is that this is very, very simple to do. You could decide now you want to create your own currency. You can just use one of the many templates that exist. This one is called an ERC20 token, which basically means it's like the template for a currency. So you can create your own currency whenever you so wish. And this is a very interesting kind of experiment, right? It's not like you could, up until quite recently, basically make your own form of money over the space of a few hours. It would take you maybe 2 days to learn how to make your own currency on Ethereum. Not that I encourage you to do that, because there's like a lot involved in the community side. So we are able to create these assets. And then another nice aspect of this, another thing that flows very naturally from it, is we can also create smart contracts for the swapping of these tokens, right? So now we've got assets. We're able to create our own type of money. We can even create our own type of money to back our project. So for example, we can see one here at GTC. That's the currency of a project called Gitcoin. So that's their currency that they created. And then people who are a fan of Gitcoin buy that currency, giving it value, and then that's able to fund the things that they're interested in. Now, the nice thing about decentralized finance on the Ethereum blockchain is we can use, again, this is a smart contract. It's called Uniswap. We can go onto this Ethereum smart contract. We can connect using our MetaMask. So my MetaMask, you can see here, it's actually connected in, right? So it's plugged into the Uniswap smart contract, which itself is on the Ethereum world computer, right? So a decentralized experience all the way through. And I can swap any token that's on the Ethereum blockchain frictionlessly with any other. So I can decide, if I so wish, to move from Ether, the currency, over to GTC. Maybe I change from GTC over to another one called like Uni, which is their token. And I can frictionlessly just move between any of the tokens. And again, all of this is permissionlessness, right? So this is economic activity, pure finance, the creation of currencies themselves, the swapping between any of the currencies that exist in this decentralized web experience without any permission required, without any banking, without any KYC, without any AML, without any kind of babysitters, as the DeFi people would tend to put it. They call these people degens, as in degenerates. They're focused on money a lot. OK, so on to the more fun one, or at least the one that some of you might recognize. If you have an asset like Ether or Gitcoin or anything like that, we call that a fungible token, right? A fungible token simply means something that is exchangeable like for like with any other. So let's say we take the case of a euro. Any euro is the same as any other euro. Any dollar is the same as any other dollar. Any Bitcoin is the same as any other Bitcoin, right? There's no, like, if you had like a euro here and a euro here, there's nothing really to make you choose between them, right? They're the same thing. Maybe there's like a slight imperfection or something like that. So fungible tokens are these. These are exchangeable like for like. They're just currencies that we're used to in the real world. Now, it's also possible in Ethereum to create what are known as non-fungible tokens, which are obviously going to be the opposite, right? So if we can create fungible like-for-like tokens, we can also create what are known as non-fungible tokens. In this case, what we're going to do is we're going to create a set of things that are similar. So we might create, let's say, 10,000 cats, or the example we'll see in a moment, which some of you may predict, 10,000 apes. And we give them unique individual characteristics within the set. So let's say we've got 10,000 of the same cat, but we give each cat its own unique token, and that token has associated metadata which says the cat is pink, the cat is like standing up, the cat is green, etc., whatever kind of traits that we want to put in. We might also put a little link in that points to the image, and we can create like a nice image for the cat. So we can create these one-off tokens that are associated with like rare characteristics or rare traits. And that's what an NFT is. So when you hear the term NFT, you're most likely thinking of those images. But the actual reality, what is the NFT, is that token that gets created on the Ethereum blockchain in a particular smart contract. So here's an example. This is a classic game. By classic in crypto terms, we mean it's like 2017. So we call these vintage NFTs. So anything before around 2019 is considered vintage. We even have people called NFT archaeologists who scour the blockchain for like old vintage NFT artworks, right? So anything before 2020 is sort of like old at this point. That's how fast it moves. So in this project, the developers created a game called Moon Cats Rescue. So they create 10,000 of these cats. They give all the cats their own unique token. They give the cats then like kind of unique characteristics, like it's sitting down, it's pink, all those different kind of things. And then they allow users to send Ether, the currency, to the smart contract, which then sends them back the token or the non-fungible token asset. So now you've got a game that you've created on the Ethereum blockchain around collecting rare items. And then people can trade the Mooncat in their MetaMask wallet. And now you've got the exchange of non-fungible tokens as well. So we've got the exchange of fungible tokens in the form of decentralized finance, and now we've got the exchange of non-fungible tokens in the sense of art. So we've got economics and we've got art under our belt. And that's two aspects of Web3 which are leading us toward the idea of an expansive sense of what cryptocurrency and Web3 potentially could be. Okay, by the way, the idea is that when you rescue the cat from the moon, they cease to be orphans because you've kind of like collected them, and that's sort of where they come up with this idea. Okay, now not all NFTs are like this. In fact, most aren't. But I feel it's worth showing people the most extreme examples. So this is the Bored Ape Yacht Club. This is a 10,000 PFP non-fungible token project, which means there's 10,000 of them. They're typically used for profile pictures on Twitter, stuff like that. But what are they in reality? They are a smart contract with 10,000 NFTs, an individual token. That token contains characteristics, like the ape should look like X, Y, and Z. You know, it should have like bunny hat on. It should be like, maybe he's wearing a jacket. And those traits are on the Ethereum blockchain, right? That's what people are buying. But then they usually point to an image as well, and that image is going to be what most people sort of accidentally believe an NFT is. So many people believe the NFT is the picture, so they'll say things like, can't I just right-click the picture? And well, I mean, you can definitely just right-click the picture, but that's not really what these people are buying. They're buying the token on the Ethereum blockchain, which is an important distinction because you will never understand NFTs if you believe in the superficial image kind of part of it. That's definitely not what's happening. So the value you can see here is quite extreme. The floor price, meaning the cheapest Bored Ape that you can buy in this image, is 91 ETH, or around $172,000, right? So these are blue chip tier NFTs. This is not something that's going to happen too much. I know one guy in Ireland who has this, and you know, he's become a very happy person since he accidentally bought this project on a whim, and then his one is worth, I think, $350,000. So I can't believe he didn't tell me, but you know, that's how it goes. And this is on a marketplace called OpenSea. If you're interested in looking into NFTs, OpenSea is the name of the marketplace. You can then connect your wallet in and like buy those NFTs from the marketplace, but you're probably not going to get a Bored Ape. Now, when it comes to this, I think it's worth stressing that people definitely struggle with the idea of why are NFTs valuable? And I think it's just helpful to pitch this in terms of subcultures. So my research is very focused on the idea that cryptocurrencies are cultural expressions. They're not necessarily always economically focused. They're social entities. They're very focused on community. People enjoy being part of them. It's fun. It's creative. It's a sort of interesting world. This is overlooked a lot in what I see in the media when people talk about them. So if you want to understand the Bored Ape group, it's probably best to simply look at when they meet up and hang out. They have like, you know, nightclub events where you can only enter if you have the NFT like on your MetaMask wallet on your phone, which gives a sense of like exclusivity and access. So it won't make sense to you, like why would someone pay so much? But it does make sense if you begin to see it as a subculture with a certain amount of exclusivity built around it. Examples of Bored Ape holders as well. There's a celebrity aspect to this, which is that Eminem, Paris Hilton, and Jimmy Fallon all own Bored Apes as well, right? So it's also got this celebrity angle to it. Okay, so we're veering toward the end. We have finance, we have art, so finance and art. So I think these are pillars of any kind of society. In my, some of my research, I call these decentralized analogs to state functions, which is a very fancy way of saying that cryptocurrency and Web3 is basically trying to build all the pillars of society, but in a decentralized way instead of a centralized way. So as our society becomes more, as the lack of trust in our institution becomes more and more apparent, we begin to see attempts to basically create alternatives. And I see this group as very much involved in this. So the most science fiction-y name of this of this set of technologies is coming up. This is the Decentralized Autonomous Organization, right? So the Ethereum community, they never go for like easy terms, right? Smart contracts, non-fungible tokens, and now they've added in another one, which is Decentralized Autonomous Organization. Very science fiction sounding, so we just call them DAOs, right? DAOs. And what these are, in reality, are essentially communities that self-organize using blockchain technology. So that's my definition of it. There isn't really an official formal definition, so like literally this is my definition being put out there. And so I would call this, so communities that self-organize using blockchains. So in the kind of Web3 world, you don't always have, say, companies that are running different projects. More likely, especially these days, you're going to have communities that are running projects or involved in projects that they manage along decentralized or non-hierarchical lines, right? They don't have bosses, they don't have central authorities. They organize themselves as collectives and communities using blockchain technology. We'll see how they do this in a moment, but I just want to show briefly the kinds of things that they're interested in. Because DAOs, they don't have any particular focus. Right? The goal of a DAO can basically be anything. If we form together 5 of us just to have like a game of football and we organize ourselves using a blockchain, that's a DAO, right? And if there's 10,000 of us, like in the case of Gitcoin, where we're organizing like the funding of open source development in Ethereum, well then that's also a DAO, right? And it can be anything. Any goal, any interest we have can be a DAO. There's also like an Irish student organization called Blockstock, which is students who organize crypto events as a decentralized autonomous organization, for example. So here's some examples, some famous examples. We see investment DAOs. So some DAOs are interested in, of course, right? This is very common in crypto, investing in different things, investing in currencies, investing in NFTs, all that good stuff. We've got collectors DAOs. So these are people who collect different types of artwork in the crypto space. That can be done for like financial motivation, but actually many of these DAOs are just focused on particular artists. So up the top there is Pleaser DAO. So that's just a DAO that collects the work of an artist called People Pleaser, who's just like a famous crypto artist. Then we have social DAOs. So FWB, Seed Club, and another example here, we see Bored Ape actually down there as well. So these are social groups that organize using blockchain technology, meaning they have real world events, they hang out in person, they've got places all across the world where if you turn up to that building and you show that you're a member of the DAO, you can hang out there. So they're social organizations. We also have media DAOs, so these are alternative media or niche media or podcasts that are like, purely crypto native that are organized as DAOs. So what exactly is involved in this, in the practicalities? Okay. So a DAO will have 3 elements usually. I call this the hash bash cash model of decentralized organization. I'll call this is the bash part. This is the social element. So most DAOs, they usually organize in Discord. So some of you may know Discord from like, gaming and that kind of thing. Or they might organize on Telegram, which is another app that some of you might be familiar with. But essentially, they'll just need to have some place where they all hang around, discuss issues related to the DAO. So they'll just have a place online where they discuss issues of shared interest. Very often, they'll have a governance forum. So this is a community which is going to govern itself using blockchain. So when they make decisions about what they're going to do, whether to invest in art, whether to host a night next month, whether to charge people to enter the event, whatever it is that the DAO is trying to do, they will go to the governance forum and they will say, okay, this is what I think we should spend the DAO's money on. So the DAO will have a treasury of money that people will have, that will have been earned by people buying the token of the DAO. So we'll have a money that we'll need to manage. So here's an example of what's known as a blockchain vote. So when is it that they become sort of a bit different than just a community or a club? It's when they engage in what's known as blockchain voting. So far we've focused on the idea of assets, right? Using the blockchain to record either, let's say with Bitcoin, right? We're recording Bitcoins in Ethereum with Ether. Then we have those like fungible tokens, the DeFi tokens. Then we also have NFTs. All those are kind of like digital assets on a blockchain, and that's like a primary use of the blockchain technology. But this is a different use. This is a social use of the blockchain. So what we're going to do here is we're going to use the token of the DAO. So the DAO will create a token when it launches. Users who want to be a member of the DAO will buy that token. That's where the treasury comes from. And if you buy that token, that then gives you the right to vote on matters of how the DAO proceeds. So ownership of the token equals community membership of a decentralized autonomous organization. So now we have this new way of being a member, which is, of course, like token-based. And so when somebody thinks that something is important enough, they will put this to what's known as a blockchain vote. And they'll explain their reasons for what we need to do. So this guy is explaining we need to spend our budget for the next, say, season, as they call it. So let's say 4 months or something. This is how I think the money should be spent. And then the community will look at their summary. They might discuss it a little bit more. And then it will go to a vote. So the way that the vote works, this is a tool called Snapshot. So Snapshot is a smart contract. So this is, again, something that somebody made as a smart contract, sent to the Ethereum blockchain, and then people can interact with it, right? So this is something that people created actually like for free, just a tool that anybody can use. So you can create your vote, and then you use your token, you connect into Snapshot, and then you, if you've got tokens, you're not spending your tokens. You're just like, if you have ownership of it, then you're able to vote. And then you vote yes or no, and then this will show up at a certain block. So we will say something like at block, let's say, I'm going to simplify this. Let's say at block 700, the vote ends, right? So at a certain block, we will be able to see the results of the vote. Because remember, everything on the blockchain is completely transparent. So we can use the idea that the blockchain is like a shared digital ledger where everybody can see everything happening as a way to have completely transparent votes. So it's a very interesting way to govern yourselves in a very democratic, open, transparent manner. So, okay, the bad stuff. So we're nearly at the end here. So I've been telling you all the good things. So I'm an advocate of cryptocurrencies, you might have picked up, right? A believer. Hodler, whichever way you want to see it, an Ethereum. So I believe that at the very least there's something valuable in this experiment, you know, that it's an interesting kind of thing that's happening. But I have a relationship with it which is similar to the relationship we all maybe have with our families or our friends, where we don't like when someone external to it kind of like makes fun of it or critiques it. Then you become like the biggest defender, right? Then you're like, you know, you can't say that about this. This is like my thing, my family's thing or my friend's thing, right? But amongst my friends and family, I can be extremely critical. And in fact, most of the articles that I write for the crypto space are very, very critical and very much calling out what I see as bad behavior in the space. So a good example of this is the trash mo, when the media lies about crypto. So the idea here, this is an article that you can see on Yahoo. It's on CoinDesk as well. And you can just kind of like flick through all my different articles about this. And the idea of this piece is that in order to get to the good stuff in crypto, so let's say in the middle of crypto, you've got this authentic experimental world of DAOs, DeFi, and NFTs, the trifecta of smart contract applications built upon Ethereum, built itself upon the Bitcoin project, right? So this really, really interesting story of kind of cryptocurrency development. But then surrounding it is this huge moat, the trash moat. And that's all the people who are trying to part you from your money by getting you involved in like really low quality scams, whether that's like YouTube influencers, whether that's your friend who's asking you to invest in something in a WhatsApp group, whether it's the Red Top Media, the Sun and the Mirror, they now have dedicated pages to crypto where they basically promote what I would see as like very, very low quality projects. And so there is a huge danger in getting involved in crypto because you are green, you're the retail investor or the average Joe, as they sometimes call it, and this person is the target of the cyber criminals, of the scam artists. So you are going to need, and this is my suggestion for anybody who's going to get involved, because a very common question I'll get is, like, should I invest in X, Y, and Z, right? The most common question I get in my life relentlessly is something along those lines. I think it takes around 6 months of learning. So it will take you around 6 months of familiarizing yourself with the cryptocurrency space in order to immunize yourself against the trash moat. So if you are interested and intrigued by this project, that is my time frame before you ever involve money. That you would need about 6 months of reading to discover who are the right people to follow, what are the proper sources, and also just to see a few scams happening that you're not involved with. You just hear about them in the media, and then you can identify what are the types of scams, right? So you'll become inoculized or immunized against it. The other thing, of course, is the volatility. The number doesn't just go up, right? The number doesn't go up all the time. We're in what's known now as crypto winter, right? So we have these winters where the market crashes out of nowhere. A couple of months ago, just out of nowhere, you wake up one day, everything's going well, and then the market crashes like 20%, whatever. And it keeps going down, keeps going down. Ethereum, in particular at the moment, is really, really sort of hurting. And that's something you become familiar with over the long term. So I've seen about 4 crypto winters at this point, so it doesn't really faze me, but it is something you have to expect is going to happen. So there will be a crypto winter, so you need to be someone who's thinking very long term as opposed to short term gains. You're not going to be able to outcompete a market this new, and you're not going to be able to outcompete the people who've been involved in it for a long time. So I'll end here on the idea just of why it's still worth, paying attention to. To my mind, crypto or Web3, right? It's a remarkable economic, social, and cultural achievement, right? This is something that comes from nothing. This comes from simply a group of open source volunteer developers, people like myself running Bitcoin rigs back in the day, and suddenly flowers into something we take a little bit more serious that slowly enters the curriculum of a business school at the fringes and then kind of slowly, moves in bit by bit and then slowly begins to attract more and more people to lectures. I remember going to Bitcoin events in Dublin in 2012, 2013, and there was 5 other people. It was the most depressing thing you could ever imagine. There definitely wasn't mainstream interest in it at that time. So it's a remarkable achievement how far it's come. It's also one of the few evolving experiments that you're going to see in your lifetime. How many things like this are you going to see that emerge completely from nowhere as experiments in like economics and finance, right? It's not something that's very common. It's a very unique thing to happen. New types of money, the ability to create your own money, the ability to organize yourself in a completely distributed way, the ability to sell $172,000 apes, right? All from a simple white paper. So all of this goes back to this pseudo-anonymous developer, Satoshi Nakamoto, which I think makes it all the more remarkable. So I'll end there just with, if you want to find me, my Twitter is PolarPunkLabs, and then my email is at UCD there as well. Okay, I'll stop there.